Hi, hello everybody. This is your Srinivas. Welcome to Srinivasa Academy. Dear friends, please like, share, and subscribe my YouTube channel Srinivasa Academy. And also you can download Srinivasa Academy app from Google Play Store for more courses. Dear friends, in this video, I'm going to explain you an important concept in quadratic equations. That is sign of a quadratic expression. Most of the students and faculty get confusion at sign of quadratic expression. So I will try to explain with details. Okay. See, sign of a quadratic expression in that first statement. We can discuss sign of a quadratic expression in three cases based on the discriminant. In that first case, if the roots of ax square plus bx plus c is equals to 0 are imaginary, then ax square plus bx plus c and a have same signs for all x belongs to R. Okay? See, ax square plus bx plus c can be written as a into x square plus b by a x plus c by a. Okay, this is the expression. In this right hand side, a into, while converting into perfect square, already I have explained in our earlier videos. In order to convert into perfect square, write x as it is, and whichever the x coefficient, make it half, write whole square, minus subtract the square of the second term, b square by 4a square plus c by a. Okay, look at this, a into, or otherwise left hand side, ax square plus bx plus c by a is equals to x plus b by 2a whole square plus 4ac minus b square by 4a square. Do observe that by taking LCM, I'm writing positive term first. And already given in the statement, roots are imaginary. Roots are imaginary gives us b square minus 4ac less than 0. Whenever b square minus 4ac less than 0, 4ac minus b square greater than 0. Dear friends, x plus b by 2a whole square plus 4ac minus b square by 4a square. Listen here carefully. Nothing is there in this. Just we need conscious on whole square and this term. X plus b by 2a whole square. We know very well that the whole square quantity is always either greater than or equals to 0. X plus b by 2a whole square greater than or equals to 0 for every x belongs to R. So this is either greater than or equals to 0. But 4ac minus b square is positive. Denominator 4 times a square is also strictly positive. Positive by positive is always positive. It is either positive or 0. Even in case of 0, it is positive. Even if it is positive, positive plus positive, also positive. Finally, what I am going to say is ax square plus bx plus c by a is greater than 0 for all x belongs to R. For all x belongs to R. My dear friends, do observe that numerator by denominator positive happens when numerator by denominator positive ఎప్పుడవుతుంది? Both numerator and denominator positive, resulting fraction is positive. Both numerator and denominator negative, then also numerator, then also fraction is positive. So this by this is positive happens only when ax square plus bx plus c and A have same signs for every x belongs to R. This is the statement. In case of roots are imaginary, the coefficient of x square A and the whole expression ax square plus bx plus c will have same signs for all x belongs to R. This is a very, very important statement. Suppose A is negative, ax square plus bx plus c is also negative for all x belongs to R. Suppose A is positive, ax square plus bx plus c is also positive for all x belongs to R whenever roots are imaginary, whenever discriminant is less than 0. So this is the proof. Very easy proof it is. Okay. Next. See. So if the roots of ax square plus bx plus c is equals to 0 are real and equal, then ax square plus bx plus c and a have same signs for all x belongs to R minus of singleton set minus b by 2a. Observe that previous statement, roots are imaginary, quadratic expression ax square plus bx plus c and the x square coefficient a having same signs for every x belongs to R. Now also having same signs for every x belongs to R except one real number. Why it happens? Let us see. Ax square plus bx plus c is equals to a into same as previous b by a x plus c by a. Here we get ax square plus bx plus c by a is equals to, we can also write it as a perfect square minus b square by 4a square as earlier plus c by a. Right hand side we get x plus b by 2a whole square plus 4ac minus b square by 4a square. Observe that in the given statement, nature of the roots real and equal. If the roots are real and equal, delta is equals to 0. Delta is equals to 0 stands for b square minus 4ac is equals to 0. It gives us 4ac minus b square is equals to 0. That's why ax square plus bx plus c by a is equals to x plus b by 2a whole square. Do observe that x plus b by 2a is equals to 0 for x is equals to minus b by 2a, and x plus b by 2a whole square, x plus b by 2a whole square, whichever the value of x you take, it may be minus b by 2a, it may be other than minus b by 2a. In case of minus b by 2a, its value is 0. If it is not minus b by 2a, however it is whole square, it is greater than 0. So it is always greater than or equals to 0. But it is strictly greater than 0 happens when x plus b by 2a whole square strictly greater than 0 for x not equals to minus b by 2a. If x is equals to minus b by 2a, what will be happening? Its value is 0. X not equals to minus b by 2a, its value is always positive. So whenever it is positive, ax square plus bx plus c by a is positive. For x not equals to minus b by 2a, what it says? It is greater than 0 for every real number except minus b by 2a. That's why our conclusion, ax square plus bx plus c and a have same signs for every x belongs to R except minus b by 2a. How to write except minus b by 2a? Subtracted minus b by 2a from set of real numbers. So this is the second important statement. Whenever roots are real and equal, then ax square plus bx plus c and a have same signs, not for every real number except one real number, that is minus b by 2a. That minus b by 2a becomes root of this quadratic equation as we discussed in our earlier videos. Okay, let's go to next theorem statement. See, one more statement. If alpha and beta are roots of ax square plus bx plus c is equals to 0 and alpha less than beta, it is very clear that alpha and beta are roots such that alpha less than beta. We can conclude that they are real and distinct roots. Why? Because if they are complex numbers, between two complex numbers, inequality does not hold. We are unable to decide one complex number is greater than another complex number. We are able to decide one number is less than the other only when they are real. So that's why, in other words, here alpha and beta are real and distinct roots. See what is happening here. Ax square plus bx plus c and a have opposite signs for alpha less than x less than beta. Same signs for x less than alpha or x greater than beta. Okay. So far, in the previous two statements, we have observed that ax square plus bx plus c quadratic expression and x square coefficient a have same signs for which values of x. First time we are getting opposite signs case also. Okay, let us try to prove it. See, since alpha and beta are the roots of this quadratic expression, we can write it as we can also write it as ax square plus bx plus c by a is equals to x square minus of minus b by a times x plus c by a. However, this plays the role of sum of the roots and this is product of the roots. We can also write it as x minus alpha into x minus beta. Okay. See, ax square plus bx plus c by a, to decide the signs of these two quantities, it is enough to find the sign of their ratio. So that's why ax square plus bx plus c by a value we are getting as x minus alpha into x minus beta. Case 1, suppose alpha less than x less than beta. Alpha less than x less than beta, what will be happening? X is greater than alpha and x is less than alpha, indicates that x minus alpha is negative, x minus beta is positive. This is a negative, this is positive. Minus into plus will be minus. That's why this is negative. That's why ax square plus bx plus c by a is less than 0 because its value is this ratio. Do observe that numerator by denominator is a negative happens when both have opposite signs. Numerator plus, denominator minus, or numerator minus, denominator plus. Finally, if they have opposite signs, then only their ratio is negative. Here the conclusion is ax square plus bx plus c and a have opposite signs. Okay, so if alpha less than, whenever x lies between alpha and beta, what happens? Ax square plus bx plus c and a are having opposite signs. Now second case is also there. What is that second case? We can split into two cases this. Okay. In the second case, x less than alpha. Consider x less than alpha. And also given alpha less than beta implies that x is also less than beta. X less than alpha, alpha is the least root, x is lesser than the least root, and beta is the greatest root. Obviously, x is also less than beta. Suppose alpha is 10, beta is 15. X is less than 10 means obviously x is less than 15. It happens. See, x less than alpha goes to x minus alpha less than 0. X less than beta goes to x minus beta less than 0. What happened now? Both are negatives. Both are negatives means their product is positive. Their product is positive means ax square plus bx plus c by a is greater than 0. So numerator by denominator is positive happens when they have same signs. Or x greater than beta. Very clear, beta is greater than alpha. X greater than beta and beta greater than alpha gives us x is greater than the greatest root. Obviously, it is greater than the least root. Alpha is 10, beta is 15. Let us assume, for example, x value greater than 15 means x value obviously greater than 10. This gives us x minus alpha positive, x is greater than alpha, and x minus beta also positive. Both the factors are having positive sign means their product is also positive. Their product positive, ax square plus bx plus c by a is also positive. So finally what happens in these two cases? X less than alpha, we are getting ax square plus bx plus c by a is greater than 0. X greater than beta, we are getting same thing. So that's why ax square plus bx plus c and a have same signs. Ax square plus bx plus c and a have same signs. See, in this case, hidden condition is b square minus 4ac greater than 0. Why? Because roots are real and distinct. Whenever alpha is less than beta, we can conclude that roots are real and distinct. If roots are real and distinct, b square minus 4ac greater than 0. My dear friends, so far we have seen roots are imaginary, sign of quadratic expression with x square coefficient. Roots are real and equal, sign of quadratic expression with x square coefficient. Roots are real and distinct also, sign of quadratic expression with x square coefficient. So we can take some examples. See, one example. Discuss the sign of 2x square plus 3x plus 4. Dear friends, how will be the sign of this quadratic expression? So far we have seen three statements, means three theorems based on the nature of the roots. See, let us check first it goes to which case. In the quadratic expression 2x square plus 3x plus 4, a value is 2, b value is 3, c value is 4, and b square minus 4ac, 9 minus 4 into 2 into 4, 9 minus 32 minus 23 is less than 0. So roots are imaginary. Roots are imaginary. Which roots are imaginary? Such quadratic equation. Actually, this is quadratic expression. So b square minus 4ac less than 0 means if we write is equals to 0, we get two roots. Those two roots are imaginary. In case of roots are imaginary, we are having a statement that coefficient of x square and whole expression will have same signs. Here the coefficient of x square is what? Coefficient of x square 2 greater than 0. Expression 2x square plus 3x plus 4 also greater than 0. Final conclusion is 2x square plus 3x plus 4 greater than 0 for all x belongs to R. Suppose if you want to write 2x square plus 3x plus 4 less than 0 for which values of x? It is less than 0 for x belongs to empty set. There is no real value of x for which this expression is negative. అసలు దీన్ని నెగటివ్ చేసే రియల్ వాల్యూ లేనే లేదు. అన్ని రియల్ నెంబర్స్ పాజిటివ్ చేయడానికే సరిపోయినాయి. ఇంకే రియల్ నెంబర్ కూడా మిగిలిపోలేదు కదండి ఇక్కడ. సో దెర్ ఇస్ నో రియల్ నెంబర్ ఫర్ విచ్ ఎక్స్ప్రెషన్ ఇస్ నెగటివ్. That's why empty set. Or else we can also write for no real value of x also we can write. So this expression never be negative. Okay, next example, discuss the sign of x square minus 14x plus 49. Dear friends, x square minus 14x plus 49 compare with standard quadratic expression a is equals to 1, b is equals to minus 14, c is equals to 49. Also find b square minus 4ac, which is minus 14 whole square, 4 into 1 into 49, 196 minus 196 is equals to 0. B square minus 4ac is equals to 0. We can say that roots are real and equal. If roots are real and equal, we are having a statement that ax square plus bx plus c and a will have same signs for every x belongs to R except minus b by 2a. So what is minus b by 2a here? Coefficient of x square 1 positive, minus b by 2a, let us prepare and write here 14 by 2 times 1, that is 7. Therefore coefficient of x square and whole expression will have same signs. Already this is positive, expression will also positive. X square minus 14x plus 49 greater than 0 for all x belongs to R minus set of minus b by 2a. That minus b by 2a is 7. What it says? Except 7, expression is always positive. At 7, expression is 0. X square minus 14x plus 49 is equals to 0 for x is equals to 7. Where it is negative, 49 negative for no real value of x. Why? Because all the real numbers completed. For 7 it is 0, other than 7 it is positive. Real numbers are only two types. One is 7, other one is other than 7. All real numbers completed for these two cases. There is no real number left for the third case, which is less than 0. Means this expression is also always positive. Yes. Next example, discuss the sign of x square minus 8x plus 12. Do you observe that x square minus 8x plus 12, a is equals to 1, b is equals to minus 8, c is equals to 12. B square minus 4ac minus 8 whole square minus 4 into 1 into 12, 64 minus 48, that is 16 greater than 0. B square minus 4ac greater than 0 means roots are real and distinct. In case of roots are real and distinct, we have to find those roots. Is equals to 0, we have to write Factorization x minus 6 into x minus 2 is equals to 0. X is equals to 6, x is equals to 2. But according to the statement, least root is alpha, greatest root is beta. Alpha and beta. Here the coefficient of x square, 1 positive. Now let's discuss the sign. Coefficient of x square and the expression will have opposite signs for x lies between the roots. Same signs when x lies exterior of the roots. You observe that already coefficient of x square is positive. Now the expression is negative. Means these two are having opposite signs. For what values of x? Already we have derived alpha less than x less than beta. So that's why 2 less than x less than 6. Okay. Next, x square minus 8x plus 12 greater than 0 means what will be happening? Coefficient of x square and the expression is positive. Both have same signs. For x less than 2 or x greater than 6. So negative sign, positive sign. Where it will be 0 is equals to 0 for x is equals to 2 comma x is equals to 6. So this is the discussion of the sign of quadratic expression. We have discussed 3 examples based on the nature of the roots. Okay. So my dear friends, please like, share and subscribe my YouTube channel Srinivasa Academy. Thank you. Thank you very much.